Good evening, everyone. Welcome to live session 10 on a NPTEL course on mechanics of material. Today we'll discuss about the topics covered in week 10 and we'll do some problems based on that week problems. Okay. So basically, I'll give you some of the formulas which will be useful for you to help in the exercise, which will help you to do the assignment problems. Okay. So today is one. Okay. So today is second. So in the week 10 lecture, we see about mostly torsion. Okay. So in torsion, three main formulas we have seen. First is when the closed sections were there, what is the formula we'll use? Okay. So the torsion equation, basically. Okay. So the torsion equation is given by tau upon r is equal to T by J, which is equal to mu into omega. Okay. So where omega is nothing but angle of twist per unit length. Mu is nothing but shear modulus, which we also call as G. Okay. T is known as torque. J is polar moment of inertia. Which is nothing but integration of r square dA z, integration over az. Okay. Tau is shear stress. Okay, and r is the distance, radial distance. Understood? So this is a torsion equation. Okay. Then we see that whenever the warping is there and the slit is there, suppose for example, I will say, suppose we have an annular cylinder like this and a slit has been given like this. So what formula we have to use? Because now shear flow will not have a continuity over a cross section. It cannot cross this thing, shear flow. Okay. Are you getting my voice?
Yes.
Okay. So we cannot get a shear flow. Okay. Continuous. So the shear will return like this here when a slit is present. So which formula do we use? So the general formula provided is T will be given as when slit is there. So T will be equal to C1 mu omega WT cube. Okay, C1 is a constant, mu you already know as shear modulus, omega is angle of twist per unit length, W is perimeter. Okay, perimeter of mean. It is not good to say mean. Perimeter of the we'll say, like, suppose a rectangle is there, square is there. So if we define this dotted line as mean, okay, mean point of view, so the perimeter is this, represents by this dotted line. Okay, T is nothing but the thickness of the slit. Okay, and C1 is constant.
सर
Yes,
ये तो रेक्टेंगुलर क्रॉस सेक्शन का होगा ना?
square or rectangular depends upon the length. Yeah.
नहीं सर, ये सर आप जो बता रहे हैं स्लिट वन वाला सर ने बताया था T = 1/3 म्यू ओमेगा.
That is C1 constant.
Okay.
Depend upon the value of W by T. Okay, I'll just coming up to that thing only. So the tau max will be equal to C2 T upon WT square. Okay. So when a slit is there, our C1 becomes 1 by 3 and C2 becomes 3. Okay, so your formula will come like that only. T will be equal to 1 by 3 mu omega WT cube and tau max will be 3 T upon WT square. Now is it same? Here W by T tends to infinity, okay? Because the thickness will be very small, okay? The thickness doesn't mean this thickness, okay? As explained in the lecture also, this is not the thickness. The thickness will be the shear flow thickness, okay? So for the comfortability, W by T we assume is tending to infinity. That's why these constants are coming, okay? Detailed derivations are not required as of now, okay? So when a slit is there, this is used. Okay, the last formula which we use is for the thin wall section, sorry. So for thin wall sections, tau T remains constant, okay. T will be given as 2 into tau into T into a enclosed area. This is known as enclosed area, okay. And angle of twist will be given as T upon 4 mu enclosed area square line integral of ds by T, okay. So
Yes,
these are the three main formulas which you will require to solve the problem, okay. Now we'll move into the problems section, okay. So problem
सर
1,
टी जो उसमें
yeah,
क्लोज्ड वाल लिखे थे थिन क्लोज्ड वाल में,
yeah,
तो ए स्क्वायर रहेगा कि केवल ए रहेगा?
where in second
इक्वल टू
this,
2 म्यू टी ए इनक्लोज्ड एरिया.
yeah, this is A only, not square.
सर लेकिन सर ने तो ए स्क्वायर कराया उसको.
No, you must have written wrong. The torque will be given as 2 tau T into enclosed area. You can check the dimensions also. So
Yes,
this
sir.
dimension, if you check by dimension, see, tau is nothing but Newton per mm square, okay. T thickness will be in mm and area will be in mm square, okay. So mm square will cancel,
Yes.
okay. This is T, okay. So T will come out to be Newton mm, okay. If you check by dimensions, so what is the unit of moment? It is Newton meter or Newton mm, no. So it cannot be a square, okay. Got it?
Yes, sir.
So if you have some doubt in a square thing, you can check the always this dimension. Dimensions should match. Okay, this is the thumb rule.
सर ये जो आप टॉर्क मतलब वो नीचे दूसरा वाला जो दिखे वहाँ पे सर ने ए के पावर 4 कराया है.
No. That is for square section. I guess you are confusing. If we take a square,
thin wall core section.
Yeah, thin wall section. If we take a square, see, suppose if I take a square, okay, this dotted line will be A. So area of square will be A square. So enclosed area will be A square to the square, which is A4. Got it? So the formula is this. For different cases, it will change. Okay, don't confuse. Okay. So now we'll move into problem 1. So these are the three main formulas which you have to be careful. Okay. 1 second. I'll check whether the recording is open or not. Okay. Okay then. So problem 1. Oh. Yeah. So the problem statement is the shafts AC. You can write with myself, with me also. Shown in figure below. Okay. Has a solid circular cross section N is made up of same material. Okay, so both shafts are the same material. Okay, let the diameter of the shaft AC to be equal to 60 mm. Okay, and shaft CE to be equal to 40 mm. Okay, okay, and the torque applied. Three points the torque has been applied at point B, which is TB, which is equal to 500 Newton meter, at point D, which is equal to 1000 Newton meter, and at point E, which is 800 Newton meter. Okay, then you have to find the following things. The material properties have been given to us as E is 200 GPa and Poisson's ratio as 1 by 3. Okay, so I'll draw the diagram first. Okay, this is shaft A. At B point, one torque is applied. At D point, one torque is applied. And at E point, one torque is applied. So A, B, C, D, E. Okay, these are the shafts. The length given is all are at equal distance, 500 mm. Understood the question? We have a two shaft AC and AC and CE. So AC is one shaft, CE is another shaft, and the torque is applied at 3 points B, D, and E. Okay, and the lengths are given as equivalent lengths like 500 mm, 500 mm, and 500 mm for all the four distances. Okay, so first we have to find out what is the reaction torque at A. Okay, so first question will be reaction torque at A. So suppose if I will say the reaction torque at A will be the thing what will say as TA. So TA, yeah.
लेकिन टीडी पे तो 100 है 1000 है ना और टीई पे 800 है
TE is 800 here. I'll write here also. TE 800 Newton meter. TD is 1000 Newton meter. Okay, and TB is 500 Newton meter. Okay.
यस सर
Okay. Now suppose I assume a torque applied at A point in the opposite direction to that of applied at B, D, and E. Okay. So now I have to find the reaction torque at A. The same thing which you do with the force equilibrium, you have to do here. Okay. So summation of torque. Okay. 1 second. Summation of torque at A point to be equal to 0. Okay. So what it means? TA minus 500 minus 1000 minus 800 equal to 0. Okay. Understood? So TA will be equal to 2300 Newton meter. This will be the reaction torque at A. Okay. Now second question comes. Angle of twist. Okay. Phi. Okay. So three parts have been asked. Phi, what is phi at A point, phi at C point, and phi at D point. Okay. So as we seen in the above thing, this from this equation can we find angle of twist? So if I use the equation, angle of twist phi is nothing but T by mu J. Okay. Okay.
Yes.
So now mu is nothing but shear modulus G, which is given by the expression E upon 2 into 1 plus mu. Okay. So E is given to us 200 GPa, which is 200 into 10 to the power 9 Newton per meter square. Okay, upon 2 into 1 plus 0.3 is given as Poisson's ratio. Okay. If I will calculate this thing, I will get 0.75 into 10 to the power 11 Newton per meter square, which is nothing but 0.75 into 10 to the power 5 Newton per mm square. Since all readings are given in mm, I will use the unit Newton per mm square. Okay. This part is clear. How to calculate G from E and Poisson's ratio. So now mu we know, polar moment of inertia. See, AC shaft and CE shaft are of same material, but both have different diameters. Okay. And what is the cross section given? Solid circular cross section. Okay. So
Okay, sir.
JAB will be equal to JBC. See, same material, same circular section for AB and BC. So polar moment of inertia for AB and BC will be same. Similarly, polar moment of inertia for CD and DE will be same because the material is same and the dia is same. Okay. Similarly, JCD will be equal to JDE. Got it? So now JAB for circular cylinder, we saw the polar moment of inertia is given at pi r4. Okay. Which will be equal to 1 by 2 pi into radius is 30. 60 mm diameter is given to us. Okay. So if you calculate, you will get 1.272 into 10 to the power 6 mm4. Okay. Same JB also. JAB and JBC are same. So both are the same this thing. Okay. Now for JCD, you will get same solid cross section, the same formula. Only R will differ. So you will get half into pi into diameter given is 40. So radius is 20 to the power 4. So you will get 0.251 into 10 to the power 6 mm4. Up to now, any doubt?
No, sir.
Okay. So now we know polar moment of inertia for all the elements.
सर लेकिन ये फाई है, इसमें कौन सा है?
Which pair?
ऊपर जो निकाले थे फाई है, फाई सी एंड फाई डी.
Yeah. This is we didn't calculate phi so far. I just put the formula of phi. Okay. I just explain you how to calculate phi for different parts. Okay.
तो सर ये फाई
Here we calculated mu.
क्या?
This here we calculated mu, which is nothing but shear
सर ये
modulus.
JAB JBC क्या है?
This is polar moment of inertia. Okay. So polar moment of inertia for solid cross section, circular cross section is nothing but formula is half pi r4. Okay. So AB and BC are of same material and same diameter. That's why both polar moment of inertia are same. Okay.
Yes.
The diameter has been given to the question, which is 60 mm. So radius is 60 by 2, 30 mm. So half pi 30 to the power 4, which is this. Okay. Similarly, CD, same formula, because circular cross section, solid circular cross section, diameter given to us in the question is 40 mm, so radius is 20 mm. Final answer is this. Okay, got it? Okay, now I'll show you how to calculate phi. See, in the question we have given 5 different elements. Suppose I idealize this as a single line element, okay, where we have A, B, C, D and E. Okay, so they have asked what is the angle, this phi A. Okay, see, this angle will correspond to this angle also, and this angle also, because at other points also we have the load supplied, torque is applied. Okay, suppose I discretize our shaft like this. Okay, so suppose I discretize our shaft is like this. So this is A, this is B, this is C, this is D, and this is E. And our torque is applied at these points. Okay, and here is like this. Okay, so now to get the angle of twist at A point, you can see like, see, due to torque at E point, it will twist the DE portion because of torque at E point. Similarly, torque at D point will twist the section CD. Okay, similarly BC, some angle of twist will be there, and then AB, some angle of twist is there. So to calculate at the fixed point of A, you have to calculate for other points as well, and you have to add them all. Okay, so at A point, the contribution of angle of twist at each point you have to calculate. Okay, understood?
Yes, sir.
Because at A point it is fixed. Okay, so if a beam will deflect like this, so this all will have a subsequent angle of twist because of the torque applied. Okay, so all will contribute towards the twist in angle at A point. You are getting my point?
Yes, sir.
So to calculate phi at A, which will be equal to phi AB plus phi BC plus phi CD plus phi DE. Understood?
Yes.
So now we know the formula. One thing I missed here, phi is one, L is also there. Okay, because it's per unit length, no, so we will multiply by length to get the angle of twist. Okay, so phi AB will be equal to TAB LAB. Mu is constant because same material. Okay, JAB plus TBC LBC by mu into JBC plus TCD LCD divided by mu into JCD plus TDE LDE upon mu into JDE. Okay, got it? Now how to know about TAB, TBC, TCD, TDE? Because other things we know. We know the length of each element, we know the mu of each element, and we calculated the polar moment of inertia, that is J, for all element. Okay, now we don't know what is TAB, what is TBC, TCD and TDE. Understood?
Yes, sir.
So now I'll again draw this diagram. See, here 100 Newton meter load is given to us. Okay. If we go towards left for this section, no load is applied for DE. So this TDE will be equivalent to 800 Newton meter. If you draw free body diagram also for DE section, this 800 is given to you. So to maintain equilibrium, this 800 will be applied here only.
Yes, sir.
So this DE element will have 800 Newton meter torque. Okay.
Okay, sir.
Understood how I got it?
Yes, sir.
Now similarly I'll do for the CD element. Now CD. See, CD has given initially 1000 is applied.
1000. Yes, sir.
And from this, Newton's third law of motion, equal and opposite load will also act here at D point. So this 800 will also act. So now
Yes.
what is the total is 1800 to maintain equilibrium.
1800.
So TCD will be equal to 1800 Newton meter. Understood?
Yes, sir.
Now we go to BD element. Oh, sorry, BC element. So BC. See, no torque is applied to C in the question. So only what is coming here due to Newton's third law of motion, equal and opposite load will be applied here.
18. Yes, sir.
So 1800 will be applied here, Newton meter. Similarly, to maintain equilibrium, 1800 Newton meter will be applied here. So TBC will be equal to 1800 Newton meter. Okay.
Yes, sir.
Now finally, AB. For AB, at B, Newton meter load was given, no? Yes. So 500 is already applied at B. And due to Newton's third law of motion, 1800 will come.
Yes, sir.
So to maintain equilibrium at A point, what will be having? 2300 Newton meter. This is also same as reaction force we got, hence proved this thing. Okay. So TAB will be equal to 2300 Newton meter. So now you know all the torque. Okay. So now we calculate phi A. Okay. So phi A will be nothing but TAB. Sorry, phi A. No, phi AB, phi A. Phi A. It will be nothing but TAB. TAB is 2300 Newton meter. We are taking unit as Newton mm. Okay, so we'll multiply by 1000 to convert in mm. Okay. Into LAB. LAB is given as 500 mm. Okay. Mu divided by mu. Mu is nothing but we have calculated 0.75 into 10 to the power 5 Newton per mm square. And JAB we have calculated here. See.
सर लेकिन इसमें L का तो वो किए नहीं है.
L is given in the question, no? This thing.
तो सर हम लोग इस क्वेश्चन में नहीं लिए थे ना.
हाँ भैया.
JAB निकाल रहे थे तो उसमें L.
JAB no L is required for JAB. Since circular cross section is given, the formula is half pi R4. So radius. Got it. So now JAB is nothing but 1.272 into 10 to the power 6. Okay, this is pi AB. Okay. Now pi BC. TBC is 1800 into 1000 Newton mm. Length is 500 only. Mu is same 0.75 into 10 to the power 5. Okay. And JBC is equal to JAB. Okay. So this is phi BC. Understood?
Yes, sir.
Plus now next is phi CD. So same load is there. Torque 1800 into 1000. Length is 500. Mu is same. Now JCD is 0.251 into power 6. Okay, this is phi CD. And last is phi DE. So phi DE is torque is 800 into 1000. Length is 500. Mu is 0.75 into 10 to the power 5. And JDE is similar to JCD, 10 to the power 6. So this is phi DE. Okay. So if we calculate, we get phi A as 0.09054, which is equal to 90.54 into 10 to the power minus 3 radian. Okay. Okay. Any doubt?
No, sir.
So this is first part, phi A. Now we have to calculate phi C. So now for phi A, when we are calculating phi A, we took the angle of twist for AB, BC, CD and DE. So now if we have to calculate for C, are you getting my point?
Yes, sir.
So what angle of twist we have to take?
Phi C पे
Huh? See,
CD plus
for
D.
A part, see if we have to phi A thing, okay, phi A thing, angle of twist for A section we have to given for A element, okay. So we have to take the angle of twist then did by the other elements AB, BC and
DE.
DE. Got it?
Yes.
This part. Okay. Now you have to go for the C thing. Okay. So for C thing, which angle of twist you will take care? See, if I draw this thing, this line,
Yes,
this
sir.
angle is phi C, angle of twist. Okay. Or this angle can be phi C because vertical opposite angle. Okay. Okay.
Yes, sir.
So for phi C, we'll take AB and BC. Okay. Any doubt?
No, sir.
Okay. So for phi C, we'll calculate phi AB plus phi BD. Okay. This is the magnitude of twist. In the formula, top part, this omega is nothing but angle of twist per unit length. So we are multiplying by length to get the twist. Okay, magnitude. That is why I am writing the unit as radian in the final answer. Okay, this you should know all these things. Okay. So now phi AB is nothing but TAB LAB by mu into JAB plus phi BC will be equal to TBC LBC by mu into JBC. Understood this thing? So TAB TBC we have calculated earlier. What is TAB? 2300 into 1000. LAB is nothing but 500 given in the question. Mu we calculated 0.75 into 10 to the power 5. And JAB is nothing but 1.272 into 10 to the power 6. plus TBC 1800 into 1000, LBC is 500, mu is 0.75 into 10 to the power 5, JBC is same 1.272 into 10 to the power 5. So if you calculate all these things, you will get 0.0214, which is equal to 21.4 to 10 to the power minus 3 radian. Okay, got it? Any doubt?
No, sir.
No, final ask for 5B, I guess.
5D है सर सर
5D, okay. 5B will ask. 5D is simple. See, 5D you have to add CD also, okay? 5AB plus 5BC plus 5CD will give you 5D, okay? Okay? Okay or not?
क्या सर क्या बोले एक बार 5D के लिए
See, 5, see, when we are calculating 5A,
हाँ
when we are calculating 5A, when we are calculating 5A, we added 5AB, 5BC, 5CD, 5DE.
yes
Okay. When we calculated for C part, we calculated 5AB, 5BC. Now if we calculate for 5D, it will be 5AB,
5A 5B plus 5C
5CD, not 5C. Okay.
वही सर 5A
CD, हाँ. Okay. So now we'll calculate for B part. Okay. B part will be simple. So for B also, what 5 you will calculate? Only 5AB. Got it?
yes sir
So 5B will be equal to 5AB, which is nothing but 2300 into 1000. Length is 500. Mu is 0.75 into 10 to the 5. And JAB will be equal to 1.270 into 10 to the 6, which is equal to 0.01205, which is equal to 12.05 into 10 to the power minus 3 radian. Now you understood how to calculate the angle of twist? So this is the first question, okay?
sir
Now we'll, yeah.
कुछ नहीं हो गया सर
Understood now?
yes sir
Okay. So now we'll move to second question. This is the first question based on the torsion formula. Now second question we see for the, we'll include the slit part also. So how to solve the slit thing also. Okay.
yes sir
So second, problem 2. So statement is 10 kilonewton meter torque is applied to a thin walled hollow shaft of material with shear modulus. This time shear modulus is given. Okay. When they will not give you shear modulus, they will give you Poisson's ratio and elastic modulus. So to calculate shear modulus, nothing but E upon 2 into 1 plus Poisson's ratio. We saw in the first problem. Okay. So shear modulus of 70 GPa is given to us, and having cross section as shown below. Okay. So we have to find the following things. First, we'll solve for two cross section. First is hollow circular cylinder, thin walled. Okay. Okay.
yes sir
So here, one second. Okay. So, see, in thin wall things, we always work for enclosed areas. Okay. So we want to know the mean thing, mean radius or mean distance. Understood? So anywhere when the thin wall is given to you, the mean radius or the mean distance has been provided to you. Got it?
Yes.
So suppose this is a hollow circular cylinder. Okay. So this is hollow circular cylinder. So here the mean radius has been given to you Rm or mean diameter I'll say. Mean diameter given to you as 100 mm. Okay, so mean radius will be equal to 50 mm. Okay, so mean radius is this. You are getting the diagram, no?
सर ये
Rm
100
will be
क्या दिया है?
100 mm is mean diameter.
सर तो क्वेश्चन में दिया ही नहीं है, लिखे ही नहीं है. अच्छा बाहर से लिख रहे हैं वो.
Just question statement I have given to you. The problem I'll specify you one by one. Okay.
Okay sir.
So this is the first section, hollow circular cylinder thin wall section, whose mean diameter given to us as 100 mm. Okay. Now we have to find the following things. Okay, the torque has been given to us also, which is equal to 10 kilonewton meter. Will work in mm and newton, so it will be 10 into 10 to the power 6 newton mm. Okay, got it? So for thin walled sections, I have shown you the formula above. This is the formula we'll use. There's two formulas, T and angle of twist per unit length. Okay, so now in the question they have asked find the angle of twist per unit length and shear stress. Okay, okay, so shear stress tau is given as T upon 2 into T into A. Okay, and the thickness of this section is 10 mm given to us. Okay, this is also given. Okay,
Yes.
so now what is enclosed area for circle? Pi r
Pi
square.
Yes sir.
Okay,
Yes sir.
so it's nothing but pi into 50 square. Okay, so torque is given to us 10 into 10 to the power 7. This is mm square. Okay, 2 thickness is given as 10 mm and enclosed area we found as pi into 50 square. So if I solve this thing, I will get answer as I have to check. Answer I will get as 63.66 MPa. Okay, you can cross check also. Sometimes my values can be differ also. Okay, because I did fast also these things. Okay, but you should understand the logic. Okay, when a thin wall section is given to us, the formula we already know. Okay, as per the above page which I have mentioned in the very first point in my lecture. Okay, so this is the shear stress we got. Now they are asking what is the angle of twist per unit length. Formula given to us as P upon 4 mu A square and enclosed area square ds by T. Okay, so this ds of line integral, okay, this thickness is constant. Okay, and line
Yes, sir.
integral of ds is nothing but circumference. And what is circumference? Nothing but parameter. Okay, so what is the circumference of circle? 2 pi r or pi d. Understood?
Yes sir.
So T given to us is 10 into 10 to the power 7. 4 mu is shear modulus given to us 70 GPa. So 70 GPa is nothing but 0.7 into 10 to the power 5 MPa. MPa means Newton per mm square. Okay, because we are working in Newton and mm, no, so I have to convert the units. Okay, enclosed area square. So enclosed area square is pi into 50 square to whole square. Okay, okay,
Yes.
into ds by t. What is ds? 2 pi rm. Circumference divided by 10. Okay, I'll shift this GPA thing. Okay,
सर पाई ds को क्या मतलब क्या क्या लिख रहे हैं उसको?
one
2
second.
pi rm.
Yes. See, phi ds is nothing but, sorry, line integral ds is nothing but circumference, okay, or parameter. So what is the circumference of circle is 2 pi rm. So 2 pi rm is given as 50. Okay, got it.
तो अपान में सर 10 क्यों लिख रहे हैं?
T is thickness.
अपान t.
Okay.
Yes, sir.
So all things you got it. So this will give you the answer as 1.364 into 10 to the power minus 3 radian per mm. Okay, this is the answer. Okay, if they will ask you the answer is radian per meter, you will do 1.364. Okay,
सर ये पाई 50 का होल स्क्वायर है क्या?
yes, because enclosed area square, no.
तो सर पाई को भी ले देंगे.
See, this is enclosed area we calculated here. This enclosed area square. See, pi 50 square to whole square. Get it or not?
Get it, sir.
Okay. So this is the angle of twist per unit length. Okay. Now third, they will say, suppose they will make a slit in this cross section here. Okay. So now, what is the angle of twist per unit length? If slit is introduced, what is this angle of twist? Okay. So when a slit is introduced, what is the angle of twist per unit length? Formula is 3t upon mu.
सर ये किस पे बता रहे हैं? लॉन्गिट्यूडनल पे. ये मतलब किसका बता रहे हैं?
See, initially cross section is given to us, okay, without any slit. Full cross section is there, but it is a thin wall section. Okay. So we calculated shear stress and angle of twist per unit length with the help of the formulas. Okay, as shown here. Okay. Now suppose in the question they asked, this slit is introduced. I have cut this section here. Okay. So if I have slit is introduced, what is the angle of twist per unit length? Okay. Understand or confused?
Understand, sir. लेकिन if shift has longitudinal shift होगा तब क्या होगा?
वो same thing.
Okay, sir.
This thing same. Okay. Slit means a cut so that the shear won't flow continuously. Okay. In a circular manner. Okay. So as per the first page, I have written this thing now. See.
सर यहाँ पाई का वैल्यू क्या रखेंगे? 10 या 3.14 सॉल्यूशंस निकालने के लिए.
3.14 is enough.
10 नहीं कर सकते हैं.
10 where the pi value is not 10, no. Either 22/7 or 3.14.
Oh, sir. Sorry, sir. मैं वो समझ गया था.
Pi square can be G. You are saying G, huh?
Gravity आ रहा.
No. Different.
Sorry.
Okay. So initially I told you three formula. Normal torsion equation. When a slit is there, what is the tau max equation? What is the angle of twist equation, okay? And when a
sir.
thin wall section, this, okay?
Yes,
Equation. So now we have solved for thin wall section with the help of these two formulas. Okay. Now they have said if a slit is introduced, what is the angle of twist per unit length? So the formula to use is that angle of twist per unit length is given as 3t upon mu wt cube, where w is nothing but parameter. Okay. Perimeter. Okay. T is equal to thickness. Okay. So angle of twist per unit length will be equal to 3 into torque given to us as 10 into 10 to the power 6. Shear modulus given to us as 0.7 into 10 to the power 5. Parameter we calculated 2 pi rm. Circumference. And T is 10 given to us, 10 cube. Okay. Any doubt?
No sir, 2 ये W सर 2 दिया है.
W is 2 pi rm. Circumference. This thing. Parameter. Okay. This W is this 2 pi rm. Okay. So here you will get answer is 1.364 into 10 to the power minus 3 radian per mm. Above different answer we got actually.
ये तो सेम आ रहा है.
No. Above is 1.818. Okay. So understood what is the difference when a slit is there, when a slit is not there. Okay. So now I'll solve for different cross section also. Suppose now the cross section is this square cross section. Okay, so square cross section is given to us. Here the mean distance, this distance, dotted line distance is given to us as A. Okay. Okay. So now without any slit, what is the shear stress? Formula is same. T upon 2T enclosed area. So enclosed area here will be equal to A square.
A square.
Suppose A is given to us 100 mm. Okay. So it will be equal to 10 to the power 4 mm square. Okay. Understood? T is given to us earlier 10 mm. And torque applied was 10 into 10 to the power 6 Newton mm. Okay. So tau will be equal to now 50 MPa.
सर यहाँ तो 2 A स्क्वायर होगा ना?
Small a square here.
Small square.
See. Okay.
सर शेयर टाउ के लिए भी तो रहेगा ना A स्क्वायर?
Where?
ये जो आप टाउ शेयर फोर्स निकाले से मैग्नीट्यूड ऑफ शेयर स्ट्रेस.
Yes.
तो T upon 2T A स्क्वायर रहेगा ना?
Yeah, enclosed area. No, enclosed area is this. Okay.
Okay, sir.
I calculated here. Okay. Now angle of twist formula is T upon 4 mu enclosed area square line integral of ds by T. So ds, line integral of ds is parameter. So T upon 4 mu enclosed area square into 4a. Parameter square is 4 into a side into T. Okay. 4 will cancel out. T upon mu Enclosed area is A square, so A4 into A by T, which is equal to T upon,
इससे ये तो कट जाएगा ना?
yes.
Yes.
So the final formula we'll get is T upon mu A cube T. Okay. So angle of twist per unit length will be equal to 10 into 10 to the power 6. Shear modulus given to us is 0.7 into 10 to the power 5. Side cube. Side is given to us 100 mm. 100 cube. Thickness given is 10. So angle of twist we will get is 1.428 into 10 to the power minus 5 radian per mm. Okay.
Yes.
Same thing. Now here also we'll introduce some slit. Okay. So what is the angle of twist per unit length for slit? Same formula will use 3t upon mu omega t cube. Okay. So 3 into 10 into 10 to the power 6. Omega is 0.7 into 10 to the power 5. W is nothing but parameter, which is 4a. 4 into 100. And T is thickness. Okay. So the answer you will get is 1.071 into 10 to the power minus 3 radian per mm. Okay. Understood?
Yes, sir.
For different cross sections also, how to calculate. Okay. So now we'll move to third problem. So third problem statement is a composite wire made up of solid brass core and brass core with dia equal to 20 mm and an outer core of copper with dia of 40 mm. Okay. And subjected to uniform torque of 1000 Newton meter. Okay. Shear modulus of brass is given to us as 40 GPa, which is equal to 0.4 into 10 to the power 5 MPa, because we'll work in Newton and mm. Shear modulus of copper is given as 0.45 GPa, which is nothing equivalent to 0.45 into 10 to the power 5 MPa. Okay. Now I'll draw the diagram. You understand the question?
Yes, sir.
So we have a solid circular section, okay, which is made out of two materials. So this is copper, okay, and inside one is brass, okay. So diameter of brass is given as 20 mm, so radius will be equal to 10 mm, okay. And diameter of copper is given as 40 mm, so radius will be equal to 20 mm, okay. Understood? And they said torque is applied to this section, okay, which is equivalent to 1000 Newton meter, okay. So now they are asking to us is what is the maximum shear in copper, in brass, what is the angle of twist, and what is the torque in brass and torque in copper. Understood?
Yes.
So for composite section, whatever the total torque is applied, this total torque will be equal to torque in brass plus torque in copper, which is equal to the torque applied. Okay. So in the question, it is given to us as 1000 Newton meter. Okay, this is our first equation. Understood?
Yes, sir.
Suppose if you see electrical wire, inside some small wires are also there, no, and an outer coating is also there. So if you stretch the wire or if you twist the wire, both inside wire and outer coating will experience some different level of twisting. Are you feeling it?
Yes, sir.
So this is the same thing. So if a torque is applied to the whole section, some portion of the torque will be experienced by brass and some will be experienced by the copper. Okay, and the total sum will be equal to the torque applied. But the point is, the angle of twist for both the things will be same. See, if you are twisting a wire, both will rotate by same amount. No.
Yes, sir.
So the point catch is angle of twist in brass will be equal to angle of twist in copper.
Copper.
Okay. Now what is the formula of angle of twist? In the very first page we saw with the torsion equation, it is nothing but T upon mu into J. Okay. This is angle of twist formula. So TB upon mu B JB will be equal to TC upon mu C and TJC. Subscript C means copper and subscript B means brass. Okay, this will be same. So now we have unknown as TB and TC. We'll put other values. So TB will be equal to mu B is 0.45 into 10 to the power 5. Sorry, brass is 0.4, not 0.45. 0.40. Okay. JB for solid cross section is pi by 2 into r to the power 4. Okay. So radius of brass is 10 mm. Okay. JB is equal to half into pi into RB square. Oh, sorry, RB4. Okay, polar moment of inertia. And JC equal to half into pi into RC square, where RC and RB are radius of brass and copper. Okay.
Okay, sir. Yes, sir. Power 4 or
power 4 only.
4 right, na?
Yes.
Sir, very good.
Okay, which is equal to now mu C 0.45 into 10 to the power 5 into pi by 2 into 20 to the power 4, because radius of copper is 20 mm. Okay. This expression understood?
Yes, sir.
Now we'll cut. This pi by 2 will be cut by this pi by 2. 10 to the power 5 will cut by 10 to the power 5. Okay.
Yes, sir.
So now if you will see, you will get to know that TC is equal to 18 times of TB. Okay. If you will calculate this thing. Okay. This is equation 2. Okay.
TC is equal to 18 TB.
See, if you just
yes, sir.
Okay, move this thing here. Okay, you will get to know. Okay. So now this equation 2 will put in equation 1. This is our equation 1 here. Okay. So TB plus 18 TB is equal to 1000 Newton meter, because yes, TB plus TC is T. Okay. So now TB will be equal to 1 by 19 into 1000. Okay, which is equal to where I calculated. 1 second. 0.0526 into 10 to the power 6 Newton mm. Okay. Okay, I have multiplied by 1000 also for the millimeter. Okay. Got it?
Matlab, sir, 1000 upon 19 to 1000.
Yeah, this is equivalent to 10 to the power 6 Newton mm. Okay. Okay, this thing I have done.
तो ये सर ये 1000 तापमान में है कि ऊपर ही रहेगा?
ऊपर ही है.
1000 into 1000.
I'll just change it to this thing. 10 to the power 6. Okay, this will be perfect. Okay. So now TC will be 18 times of TB. It will be equal to 18 by 19 into 10 to the power 6, which is equal to 0.9473 into 10 to the power 6 Newton mm. Okay, now you got to know what is the torque applied at brass and torque experienced by copper. Okay. Now we just see what is the angle of twist. You can calculate anything, TB upon mu b JB or TC upon mu c JC. Both will get the same answer because the angle of twist is same. Okay.
Okay, sir.
So this is nothing but I'll use first one into 10 to the power 6 upon mu b is 0.40 into 10 to the power 5. JB is pi by 2 into 10 to the power 4. So if you will calculate, you will get 0.0837 into 10 to the power minus 3 radian per mm. Okay. So this is angle of twist. Okay. Now next two parts are what is the shear stress, maximum shear stress experienced by brass and copper. Okay. So from the torsion equation, tau by R is nothing but T by J. Okay.
Okay.
So tau brass max will be equal to T by J into R max. हाँ.
Angle of twist तो दोनों के लिए होगा.
Same. Yeah, but same. It will be same. No. If you calculate by this also, you will get same answer. Okay. That's what we said now. Our statement. Okay. Suppose a wire is twisted, so both will experience same angle of twist. No.
Yes, sir.
So now tau b max is equal to TB upon JB into R max. R max is nothing but maximum radial distance. So for brass, what is the maximum radial distance? It is nothing but radius. Okay. So TB is 0.0526 into 10 to the power 6. JB is pi by 2 into 10 to the power 4. And maximum radial distance is nothing but 10. Okay. Here you will get answer as 33.48 MPa. MPa is nothing but Newton per mm square. Okay.
Yes, sir.
Next is tau c max. Tau c is copper. CSS of copper. It is nothing but TC upon JC into R max. So TC is 0.9473 into 10 to the power 6. JC is pi by 2 into 20 to the power 4. R max for copper is maximum radial distance is nothing but radius, which is 20. Okay. It will give us 75.383 MPa. Okay. This is how you will calculate the maximum shear stress experienced by brass and copper. Understood?
Sir, ये R max लिखे हैं क्या?
Yeah.
Okay, sir.
So R max is nothing but maximum radial distance. So maximum radial distance for a circle is nothing but radius from the center. Okay.
Okay, sir.
For circle, if they have given you some, suppose I will tell you for exam point of view, here circle is there. Okay. So for circle, maximum radial distance is nothing but this. For brass and for copper this. Okay.
Okay, sir.
Understood? Suppose a square has been given to you. This. Okay. The wire is in the shape of this thing. Okay. Suppose this is copper. Okay. And this inside is brass. So what is the maximum radial distance? This one or this one?
क्या sir?
What is the maximum radial distance you will experience here in square?
Maximum
Radial distance from center. This is center, no?
Yes, sir.
So here you are getting maximum radial distance here at R. So if they give you the square cross section, they will ask you find the maximum tau here and here at 1 and at 2. Okay. So you have to
Yes.
find this distance. Okay. If you see your practice question also in the week 10, you will
Yes,
see
sir.
this square cross section has been given and asked find the tau at 1 and 2. Okay. So you have to calculate this distance. Okay, from center and put it at 20 and 10. Got it?
Yes, sir.
Understood?
Yes, sir.
So this is all from week 10 problem solving session. This all three questions will help you to
सर ये तीसरे
Understand.
क्वेश्चन में एंगल ऑफ ट्विस्ट क्या रहेगा?
which question?
थर्ड
Previous
क्वेश्चन
question.
सर इसी क्वेश्चन
So angle of
angle
twist
of
is the,
twist.
yeah, angle of twist is nothing but TB upon mu b JB, no? This thing. Okay.
सर ये तो दोनों पार्ट के लिए निकालेंगे ना?
Both part it will be same, no?
तो कोई एक लिख देंगे.
Yeah, anyone, both you will get same value.
ओके
See,
सर.
you can experience also, no, this thing. If you have electrical wire, if you twist that wire, inside a small wire and outside coating, both will experience same turn.
ओके सर.
However, the torque applied will be different for both of the things.
ओके सर. थैंक यू सर.
Okay. So that's all for the problem solving session. If you have any other doubt, please let me know.
नो सर.
Okay, then we'll meet next class. Okay. Thank you for joining.